If you have just come across this video, brilliant. This is going to be a video where I am going to go through the Unit 9 questions to help revise if you're about to do the Unit 9 test, if you're still you're working through Unit 9 of the Excel Higher GCSE currently, if you're doing anything at the moment in any part of the world on completing the square, solving simultaneous equations, factorising quadratics. Though this is also for my Year 10s who have got the unit test on Monday, therefore that's why I reference it a couple of times. I may also mention the fact that this is the second time I've recorded this, because this is the first time I've done it using the microphone. Because I thought, first time I recorded, I thought, microphone, do I need it, do I not? And it didn't make for a good video. So I'm going to try and do all the questions again, this time with a microphone, and hopefully people might learn something. So, there's my screen. We'll do the intro. Okay, so in order to get the best use of this video, what I recommend you do is, in the description below the video, click on the link there and you will find a copy of a worksheet with various different questions. Attempt that first. Don't watch the video and then do the worksheet. Don't watch the video just to see, oh, what does Mr. Harris say? Oh, this would be funny. Okay, do the questions first. That is the point of this video. There are 3 stages. Number 1, do all the questions yourself. Number 2, either as you're going along, do a question, then watch that bit of the video and see how you got on. And then the 3rd bit is any question you couldn't do, then go and attempt again once you've watched my video to see whether you improve your understanding of it, to see whether you've actually learned something. Because the whole point is you don't know how to do it until you can do it without my assistance. And that's the whole point, is to try and remove my assistance from your usage. And that's what you'll need. You'll also need a calculator for the calculated questions. But for now, let's get straight on with these questions, and hopefully we'll get somewhere. So here's the first question, the non-calculated questions. These first 2 are about inequalities. So what we're going to do when we do these questions, I'm going to focus on integer values of this inequality. So if I want integer values, then I only want whole numbers. That means I want the whole numbers that satisfy this. And these are the 2 bits we're focusing on. The less than or equal to and the less than. So it's or equal to -3, which means -3 is acceptable. Then we mustn't miss 0 out. It is a number. However annoying that sounds, it is a number. And it is an integer value. And then 5, but not 6, because this is less than. It is not less than or equal to. So 5, but not 6. That's 2 marks done. We're already started. We're already getting somewhere. Next one says 4x plus 5 is greater than 24. And x is again an integer. Find the smallest possible value of x. So this is how I would go about this question. I first of all solve it, and I solve all my equations in a very similar way. Normally that involves writing down underneath what I'm doing. So 4x is greater than 19. Divide by 4. Now, assuming he's watching this, a student that I was working with this week, we really went to town on trying to make sure we remembered to do that. And then what some people would like to do here is probably sensible, is turn it into a mixed fraction. And the reason for this is, we then read it again. X is an integer, so we want all the values of x that are bigger than 19 over 4, or 4 and 4/5. So 5, 6, 7, 8, 9, etc. forever. But it says find the smallest possible value of x. So the smallest one of all that list is 5. So we then write a sentence. So 5 is the smallest integer. And that'll be 3 marks. So we've got 5 already. Obviously, pause the video now if you want to go and do question 3. But if you're ready and you've done all the questions and you're now going through checking, hopefully that makes sense and we can move on. Sorry if I go too fast. I am obviously the second time I've done this, so I'm a bit overconfident. So hopefully it's all making sense so far. Next question. Solve the simultaneous equations. This means these 2 equations are working together, they're working simultaneously. So the first thing I'm going to do is label this one number 1 and this one number 2. And we're doing question 3. So, and I like a margin because I like my presentation to be nice. So this one here, the first thing I'm going to do is multiply the second one by 3. The reason I'm doing this is already 6x and I want them to both be 6x. We'll see that as soon as I get there. This becomes 6x, but don't forget to multiply all the bits by 3. And you'll notice if I copy this below, this is number 1, I've now got a situation where I've got 6x and 6x. And that's all I need is something the same. If I get them so there's something the same, I can do elimination by subtraction. Those two x's will eliminate each other. 15y minus 2y is 13y. Do not get rid of the y's. And this is the bit where the first bit, there might be a few along the way where I expect a couple of people to get tripped up. If I take away minus 4, I actually get 52 because minus 4, 48 minus 4 is the same as 48 plus 4. The way to remember this is 48 take away 4 goes down, so take away minus 4 does the opposite thing. So it goes up to 52. Now the way I know my 13 times table is just from playing cards actually. So the reason I know that 13 fours is 52 is purely because there are 4 suits and a deck of cards and each of them have 13 cards. I play a lot of cards with my family. So y is 4, but this is the second trip up. So many people do this. Once we know what y is, we have to then go and get x. So I'm going to take, it doesn't matter which one I do, I'm going to take number 1, 6 lots of x plus 2 lots of 4. We now know this is 4, so we'll swap y with 4 equals minus 4. 6x plus 8 equals minus 4. We're going to take 8 away from both sides. 6x equals negative 12. Divide by 6. Divide by 6. X equals negative 2. And I just, for consistency, I'll highlight that as well. So we've now got y and x. Now this is a good point for people to make, is that once you know in simultaneous equations that these two are the solutions, why not just write them as a coordinate pair? Because this is an x value and a y value that work. This basically says these two lines, if we were to plot them, cross over at 2, 4. We've also got question 4 here, which is an inequality to solve. So there is a small bit that might get people snagged on here. If we take 4 from both sides, we get negative 3x is less than 30. Because it's minus, and it's the 4 that's gone, the minus will stay with the 3x. If I want to get this to be positive, I'm going to times by minus 1. That's effectively changes the sign of everything. Minus 3x becomes plus 3x. And I'm aware I'm getting quite low on the screen, so I'll try and make sure it all fits in. Minus 3x becomes plus 3x. And this becomes minus 30. But wait. If I do this, the sign flips round. And it happens because we went from, we had a minus and we wanted the minus to be on the other side. So this process of timesing by minus 1 causes the sign to change round. That's very important. Then we finish off solving it. Divide by 3. X is greater than minus 10. And there's your final answer. X is greater than minus 10. Again, 2 marks for that one, 3 marks for that one. If anyone wants to pause the video now to then do question 5 and then go on with it, just give you a moment to do that and we'll carry on. 2 numbers are given as x plus 2 and x minus 5. These sorts of questions they're called reasoning questions because you're trying to work out where the maths is. But what we're saying is effectively, because of this word product, I times 2 numbers together and I get the answer 18. And this could be the area of a shape where you multiply things together. It could be any problem where you've got to multiply together. But in this one, it is 5. I want to do it like that. 5. We've got x plus 2. Now to multiply, don't put the multiple sign. Just put brackets next to each other. And equals 18. Now I'm going to expand the brackets. X squared plus minus 5x plus 2x minus 10 equals 18. Get proficient at that. Practice it until you get them right every time. Minus 3x minus 10. I've tidied it up. But we cannot solve. We've written it down, but we cannot solve until it equals 0. So let's get the 18 onto this side by doing take away 18. Giving me x squared minus 3x minus 28 equals 0. Please be careful that this is minus 28. Make sure you understand it. Then we can factorise. Now when it will factorise, we can do it by observing, but I'm going to just go through it as the step that if you can be bothered to write the steps, you'll get it right each time. If you can't be bothered to write the steps, you might make mistakes. Who am I to try and explain to you that cutting down mistakes is a great idea. 4 times minus 7. So we've got 4 and minus 7 because they add to make minus 3. And that's what we're looking for, is a pair that multiply to make minus 28 but add to make minus 3. So I'm going to put x plus 4 and x minus 7. Now when I made this question, I messed up slightly. Not a big problem. I'll still answer it. But this then makes x equals minus 4. We've got to remember the bracket makes 0. So x plus 4 is 0, so x is minus 4. And x is plus 7, because 7 take away 7 is 0, or minus 4 plus 4 is 0. That's what we want. We want the two brackets to be zeros. And we want an OR. Now, when I wrote this originally, there was only going to be one answer, because originally the question was going to be about a real-life situation where you couldn't have negative numbers. For example, the size of a field or the size of an enclosure at the zoo. But I decided to do this as an abstract question with the product of two numbers, which means I've got two answers. So although this says original two numbers, it's actually the original two pairs of numbers. Because when x is minus 4, we end up with x plus 2 becomes minus 4 plus 2, which is 2. And x minus 5, becomes minus 4 plus minus 5 is minus 9. So there's the first one. Minus 2 and minus 9. I should have said minus 2, not plus 2. And then when x is 7, x plus 2 becomes 9, and x minus 5 becomes 2. So we've got two possible answers here. I'm just going to make it nice and clear. 2 and 9 were the original planned answers, but minus 2 and minus 9 in this question work. But occasionally you'll get questions which say a real life situation, and you're expected to go, whoa, 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 whoa. Real life situation, you can't have minus numbers as the measurements of fields. So just make sure you put it in the context of what it would look like in a real life situation. Okay, moving on. If anyone wants to pause, do so now. And we'll move on to question 6. Question 6 is a pair of quadratic equations ripe for solving. And we're going to do it by factorising. Factorising is the quickest way to solve these quadratics, but not the only way, as we will use the other two ways shortly. So, A is straightforward. It already equals 0. Because it equals 0, we can go straight to the factorising. We're not going to be lazy. We're going to list our factors of minus 30, minus 1 times 30, minus 2 times 15, minus 5 times 7, no, not 7, 5 times 6, minus 3 times 10, I've missed one. But we notice that minus 3 and 10 add to make the 7 that we want. So we've got x minus 3, x plus 10, and if you only want one mark, you're done. But if you want to get both the marks and you want to fully understand the question, we've got to then solve x is going to be 3, because 3 take away 3 is 0, or x is going to be minus 10, because minus 10 plus 10 is 0. We want these brackets to be 0, remember. Therefore, we've got our solutions. I sometimes like to highlight my solutions at the end, or put a box around them, just to make it clear where the solutions are. In B, we cannot yet solve, because the rule of solving is it needs to, as we remember, equal 0. So therefore, the first thing I'm going to do is take 10x away. I want to get everything onto the left-hand side to make it 0 on the right-hand side. And when I do that, I end up with x squared minus 10x plus 21. Now the hint here is because it's plus 21, you might think, oh, it's going to be two positive numbers, but that can't give us a minus. So that tells us when we're writing down our factors from 21, it's going to be a pair of minus numbers. And there's not many, so it immediately becomes obvious that it's minus 3 and minus 7 that give us x minus 3, x minus 7. And remember, there's one of the marks, but we only get one unless we solve it. So x is 3 or x is 7. Again, I like to highlight it for consistency and to make my answers pop off the page. Hopefully that's made sense. Obviously, feel free to rewind slightly if you want to go over it again. Always, always, always show your numbers if you want to make sure that you're accurate, although I'll be honest with you, if I was doing this myself, I'm at the stage now where I just do it in my head. I do respect people doing it in their head, but I don't respect it when people then get it wrong because they were careless. So it really is your choice there. Moving on to question 7. Now, this is the first of 2 questions I've included which have like a code or a clue about what to do, but you have to decode it. And it's this. If you see the sentence written in the form x plus p squared, that is a code that should say to you, complete the square. It doesn't in the question say complete the square. You have to learn these codes, and you learn them by watching videos like this and working through the questions. So we've got complete the square. So what we're going to do is we're going to take question 7 and we're going to flip back in colour. We're going to go x squared minus 8x plus 5. To complete the square, we look at the number as the coefficient, or the number before the x, halve it, giving us x minus 4 all squared, then remove that number squared, and it's always remove, so it's always subtract. It doesn't change to a plus or a plus when it's a negative number. It is a subtraction, so we're taking away the 16. This is because when we expand it, we get this. So we still have to bring the plus 5 down. Then we tidy it up. X minus 4 all squared minus 11 equals 0. We don't have it equals 0 yet. Let's get rid of the equals 0. Equals 0 comes in part B. Because in part B it says, use your answer. Now this is not so much a secret clue as a do this. So we're going to use our answer to solve the equation. So therefore we use x minus 4 all squared minus 11 equals 0. So this works like this. We add to get to this side. It will always be add because it's always going to be a takeaway. If it was a plus, it wouldn't work because we can't square root negative numbers. So we're going to add 11 and we end up with x minus 4 all squared is 11. We then square root both sides, giving us x minus 4 equals plus or minus the square root of 11. If you just put plus the square root of 11, you've lost a solution. We now add 4 to get rid of the minus 4. So we end up with x equals 4 plus or minus root 11. And this is where I draw your attention to. It says leave your answer in served form. This is your final answer. Do not try and get your calculator to give you values. It tells you not to. So you've got to follow the question and follow the instructions. Now a quick pointer here. If you are coming here and you're rusty on your completing the square, and that's something that bothers you, if it had been, for example, a number which had an odd number, if it had been an odd number in the middle, it still works the same way, but the halfway is over 2. Only when it's odd. The other thing I sometimes see is people trying to squeeze an x in there. Don't put an x in there because the whole point of this is when you expand it, the x is produced. But this would mean we need to take away 81 over 4 because the thing you take away is the number in the bracket squared. So that's why I took away 16. Here I have to take away 81 over 4 because 9 squared is 81 and 2 squared is 4. That presents a small, tiny problem in that we can't take whole numbers away from fractions. So we turn the whole number into its fraction of 12 over 4 by multiplying both the top and bottom by 4. This means I now have 8 minus 81 over 4 minus 12 over 4 mouse back in and tidy it up. So we've got x plus 9 over 2, all squared, take away 93 over 4. Now, if any of that is confusing, watch it again slowly. Make sure you listen to what I'm saying, make sure you follow it until you can do it yourself. And then that's quite key. Keep practicing this until you can do it yourself. I've also recommended MathsBot for these questions, because if you find the questions on completing the square, you can do over and over and over until you're getting them right every time. What better can you ask? If you need to pause, do so now. If not, join me at question 10. Now, you might be wondering, does Mr. Harris know that there's no question 8 and 9? You may have spent ages looking for question 8 and 9. I do apologise if you have. But for some reason, question 8, the numbering system broke when I was writing these, and there was no question 8 and 9. I like to imagine that in years and years' time, explorers will discover this video and they'll go off or discover these sheets and they'll go off looking in caves for questions 8 and 9, the mystical question 8 and 9, and they'll spend hours and hours looking at it, but they're not there. I never wrote them. So there. Never mind, I'm not going to change it now. This is a reasoning question. What it means is the maths you know, but can you find it? So the first thing we do is the diagram shows a parallelogram shaped birthday cake. The fact that it's a birthday cake is irrelevant. The fact that it's a parallelogram, we can see that. So that first line is kind of just stating that you should be able to see a picture. This is relevant. All measurements are in centimetres. Write down a pair of simultaneous equations. Now what you have to do here is realise that in a parallelogram, those two lines are the same length. Therefore, it is fair to say that a plus 5 equals b. It is also fair to say that these two are the same length. So 5a plus 2b equals 5b minus 3a. That's what you're expected to see. The fact that there's a shape, we know about shapes that those lengths are the same. And that's how we make our simultaneous equations. Now the one thing I would do is I'd tidy this up. This has currently got a's and b's on both sides. So I would take 5b away and add 3a to get it on the other side, because it's a minus at the moment. That gives me 8a minus 3b equals 0 and a plus 5 equals b. 2 marks because I've got I've got a pair of simultaneous, a pair of simultaneous equations. Solve them. So when I do this, I know I've already done this video where I did elimination method. This is going to be the substitution method because I know what b equals. So b equals all of this. So what we can do is we can say 8a minus 3 lots of, I'm going to change colour to make it really obvious, that is b. So let's swap all of that for b. Equals 0. I probably want to go back to blue for that. Otherwise it looks messy. Now it looks even messier because I've got both. Then we expand our brackets. And this is, I've warned you, there's a couple of red flags here, a couple of times where people might make small mistakes. When we expand these brackets, most people will get minus 3a and they'll be happy with that. But some people will forget that minus 3 times 5 is minus 15. It's a common time that we see mistakes, is minus 3 times both these numbers. Then we can simplify, so we end up with 5a minus 15 equals 0, a equals 15, sorry, 5a equals 15, a equals 3. Please, by the way, if you have any questions about any of these things, feel free to ask them in the comments below the video. I will try and answer them as promptly as I can. When I get flags through when people reply to post comments on my videos, I'm more than happy to try and answer any comments if there's anything that doesn't make sense on any of these questions. So once you've got that a is 3, it doesn't ask you just to do what a is, it also says b. So we can immediately go up here and go, a plus 5 was b, so therefore 3 plus 5 equals b, so b is 8. However, because of this line here, I expect for full marks you to write centimetres and centimetres. And I know that sounds annoying. Don't care. I am annoying. But I mean it with love in my heart as I try and make sure that you understand what you're doing. We are on to question 11. And we're on the first of the calculator. So if you haven't already, grab your calculator, have a go at the questions before. So pause the video now before I start talking about them. Do the questions either on the from the screen or download the worksheets. And then when you're ready, I'll start going through them. So, solving the inequality. There are two ways to go about this. We can break this into two separate inequalities, much like this, and 3x is less than 12, and solve them both separately. But I'm not going to, because although you can, this one works perfectly well without doing that. What we're going to do is divide by 3, divide by 3, divide by 3. We're giving us x and 4 and minus 7 over 4. You do not need to use a decimal, but you do currently have a calculator in front of you, so I'd be absolutely fine with minus 1.75 if that's what you want to write. I'd be fine with minus 1 3/4. But all of those things are correct. Now for question 12, I like question 12. It is an example of when you might actually have a situation where a knowledge of simultaneous equations becomes useful. And the only real reason it's slightly more difficult than normal is that I'm going to do another margin because I'm spoiling myself with margins. I do talk too much. So we've got 4 cups of coffee plus 3 pastries is 715. The only reason it's more difficult is because there's decimals in the question. But you've got a calculator, so use it. 3 cups of coffee plus 5 pastries is £8.80. Please do not leave out that 0 because we've got to remember we're dealing with pounds and pence. So we're going to solve them using the elimination method, and I'm going to turn both of these, and I choose normally to focus on the first row. You could do this with the second row and times by 5 and 3, but I'm going to times this row. I'll do it on the arrow so we can see where I've done it. I'm going to times this row by 3 and this row by 4. My reasoning is that will produce 12c and 12c. It will also, though, produce 9p, and using your calculator, 2145, and it will produce 20p, and using your calculator, I'm going to use my calculator for accuracy, is £35, and it says 0.2, but I'm writing 20 because I know I'm working in pounds and pence. I now use the elimination method. I'm actually eliminating the top one from the bottom one, but this will give us 11p as the difference here, and 11p being equal to £13.75. I used a calculator. I don't need to try and do anything in the head or do long calculations. Please, once you're in the calculator questions, don't fall in the trap of trying to do show method by doing long calculations. You gain nothing from it except for the chance of maybe making mistakes. However, we still have to solve this and divide by 11. My calculator tells me that means that their pastries are £1.25. Pretty reasonable. As you can tell, I've eaten a lot of pasties in my time. Now, we also must find, we now know pastries, we don't know coffee. So we choose one of the originals, 4c plus 3 £1.25s is £7.15. Use our calculator throughout and we get £3.75 is equal to £7.15. Use our calculator again to subtract and we get 3.4, but I'm going to write £3.40 because we're dealing in pounds and pence, and divide by 4, divide by 4, and you get that 1c is equal to 0.85. Then I put my pounds then so that I can have it nice and clear, and you may even, because you're nice and sensible, you may wish to even write coffee, and you may wish to write that as pastry. So that you've finished the whole answer and finish it all off and wrap it all up nicely. Again, if you still haven't done 13 and 14, please go away and do those because we're now going on to 13. And this is the second question where I did say earlier there is a hint or a secret code here. When you see it say solve a quadratic equation, clearly quadratic, x squared, x and a number, but it says give your solutions correct to 3 significant figures, what it's basically saying is use the quadratic formula. It's got a hint in that wording. So do it. We have to learn by heart. Minus b plus or minus the square root of b squared minus 4ac all over 2a. I know you don't want to learn it. I know it's a bit abstract and a bit odd, but you need to, so get over it. Okay? What we then have to do is go A, B, C. And these numbers are the numbers before the x's, but don't make the mistake of missing A was 5 and B was 6. You probably get those. C is minus 7 because the minus belongs to it. Now this is how I'm going to lay this out. Obviously I wouldn't expect you to do this, but by doing this, I think it really makes it clear where everything has come from. So if I do all of this in black, and this is the joy of having colours and me loving my colours. If I now swap in, I'll go back to being red, minus 6 plus or minus 6 squared minus 4 times 5 times minus 7 and 2 times 5. If I put everything there in the calculator, that's enough. That is absolutely enough. However, I normally like to, this is purely style over substance. There's no extra marks for doing this, but I think it's far better. Is write minus 6 plus, and I've got 36 out of there in my calculator, and I've got 4 5s are 20, minus times 7 is 140. Again, the calculator does all this. Minus times a minus is a plus, so if we add 140, that's why I've got 176 here. I think your calculator actually divides it all by 2, so your calculator would probably give you minus 3 plus, I think it will also simplify this down to 4 root 11. However, we've got plus version and we've got a minus version because we've got to do 2 separate solutions. And here's like the last trap of the of all the questions I'm doing with you. I think it's the last trap anyway. This answer is 0.727. 3 significant figures, 1, 2, 3. This answer is minus 9.63. 1, 2, 3. You may observe here there are 3 decimal places in the first answer and 2 in the second one. This sometimes happens with significant figures because we count from the front but we don't include zeros. The number of decimals can be different in your 2 answers because 1 started at 9 and 1 started at the 7. Just be careful for that little trap. Okay, there's your 3 marks. We're going on to the last question now, and here is a nice 6 marker, so it's clearly a lot available here, but all we're looking for you to do is spot. An intersect is where 2 lines cross. Aha! Crossing means that they are at the same point as each other, which is the premise of simultaneous equations, is exactly what simultaneous equations means. So you look at them and go, we've got a y and a y. They're both y, so we can then write that they equal each other. So once we know that they equal each other, we now do all of our process again. I'm going to take that to the other side by taking away 3x. I'm going to take that to the other side by taking away 17, giving me x squared plus 3x, I've taken 3x away, minus 10, I've taken 17 away from 7, equals 0. I've now got a thing I can solve because it equals 0. So we can find our numbers. Minus 10 can only be minus 10 and 1, or minus 5 and 2, or minus 2 and 5, which is where we find our plus 3. So we've got x minus 2, x plus 5, and anyone who, like me, doesn't like messiness, I'll get rid of that random bracket which is floating in the middle of the world. X equals 2, x equals negative 5, put an or in the middle. But because we need to find a and b, we need to find out, we know so far that at a, x equals 2, but we don't have y. And at b, we have x is minus 5, but we don't have y. And we're then going to find the midpoint. But before I get that, let's get what a and b are. So to do this, we plug. I'm going to take the whole of this. Y equals 3 lots of 2 plus 17. So y is equal to 23. Or y equals 3 lots of minus 5 plus 17, so y is equal to 2. So that's where I get the numbers minus 5, 2 and 2, 23. If we drew these on a graph, I've got a better way of doing the graph than that. Just here, and then move it over, because that is helping no one. So hopefully everyone can see that. If I drew these on a graph, I've got these two lines. So I've got x squared plus 6x plus 7. We know it goes through plus 7. And we know it's going to be plus. It's going to go this way, so it's going to be something like this. And then the line 3x plus 17. Basically what this is saying is that these two lines cross at 223 and minus 5, 2. That's where the two lines cross. But it wants to know what the midpoint of this line is. Unfortunately, the midpoint of a line, it probably won't be exactly in the middle there. It will be something like there. We'll find out in a minute. To find the midpoint, add the numbers together and divide by 2. 2 take away 5 is minus 3, divide by 2 is minus 1.5. 23 add 2 is 25, divide by 2 is 12.5. So actually that's at minus 1.5 and 12.5 would be the midpoint there. And we check through the question, have we answered it all? There's both facts, we've found A and B, and then we've found the midpoint. So we're happy. And that concludes the whole worksheet. Now, if anyone wants to get back in touch or gets in touch with me before, obviously my year 10s have got access to me on email. But if you're in a different year 10, or you're in a year 11 and you're preparing for exams, or you're in any situation where you're learning this because you're doing a homework, you're learning things, you're welcome to contact me. I'm more than happy to answer any questions of any students anywhere in the world or England. I always enjoy getting students contacting me. If I can help you, I will. I'm always happy to do a little Teams chat or a Zoom call or something just to help if there's anything stuck. Obviously, I also do tutoring, so if people wanted to book me for an hour's tutoring or something, then they can get in touch on these email addresses. I hope this has been useful. If you're in my year 10s, then get this learnt this weekend. Sorry for the earlier problem where I had no sound. Hopefully this one has sound. I've been Mr. Harris. You haven't. Have a great weekend, and I'll look forward to seeing you soon.